Hello. So we are back, and I'm seeing on the chat that we have people that are up at 1 a.m. in the morning. So, I'm very thankful for you doing that, Ahmed. I know you don't want to miss this presentation. Greg and I put together some information about the book that we just wrote and that we launched. So it's a lot of it's all bit different in terms of how we go about the questions and some answers, but we know you will enjoy it. So without further ado, I'm gonna give you all over to the session that we did with Greg and I to just you all and get your questions ready. We'll be responding in the chat for sure. Sanya Mathura, and I'm very excited today because we get to share our book that we wrote together, Preventing Turbomachinery Cholesterol, the story of Varnish. This is the first time that we're going to be presenting about this book. So, it's very, very, very good to be able to share that with everybody at LRVS APAC today. And it was great being able to write this book with Greg, because when I first started in the industry, Varnish was now rearing its head and now coming up as an issue. And the only person that had actual white papers on this was Greg. So I was always going to Greg for advice. So comes full circle and we were able to do this book together. So very excited that we could share this with you all today.
Hi, I'm Greg Livingstone with Fluitec, and I am really excited to be able to present this today with Sanya. And we're going to bounce some questions back and forth off each other based on some of the content in our book. And so I think the first most appropriate place to start is, what is varnish?
What exactly is varnish? Now, I know when we wrote this book, we wanted to make sure that anybody picking up the book could actually start to read and understand varnish and what it means for the industry and all of these other great things. And what we did is that the first chapter in the book, we talked about the basics of varnish. We had to get that done to make sure everybody understood what we were talking about later on. And one of the good things about that chapter is that we give some definitions in the book. And ASTM actually defines varnish as this very thin, hard, lustrous, insoluble deposit. And they say that it consists of a wide range of colors. We know that for sure. And it's resistant to the removal with saturated solvents. Now, that's ASTM's definition. Within the industry, we have so many different definitions because people use varnish and they use sludge interchangeably. And what we do in the book as well is that we define varnish versus sludge. So what we say about varnish is that these are the oil-derived deposits, and they actually adhere to the insides of the equipment. And they cannot be easily removed, major difference, compared to sludge, which we identify as a wipeable deposit. So that's just one of the things to, keep in mind, the differences between varnish and sludge, because they are used interchangeably throughout the industry. Now, the thing about varnish is that you can either have hot varnish or you can have cold varnish. A lot of people are familiar with the cold varnish in that this is when you have the accumulation of the degradation products and they reach a saturation point in the oil. And then they precipitate out of the fluid onto the internals and cause a bunch of different, problems. But this is when you have that drop in temperature. So that is cold varnish. And usually you could detect this with your MBC patch test. With hot varnish, on the other hand, it's when you have, the deposits are actually formed directly at the heat source. So this is when you have like a combination of high speed, high load, and usually get a lot of shear stress in extremely high localized temperatures. So the MBC patch test may not pick up on this one, but a solution to this is actually using like a solubility enhancer. So those are some of the, differences between varnish. And, we talk about this a lot in our first chapter of the book, where we talk about the basics of varnish, just getting it right.
Excellent, Sanya. Thank you. I think now we're all on the same page on actually understanding what varnish is. So the next question I have for you is that there is a myth in the industry that the root cause of varnish formation is the switch from API Group 1 base stocks to API Group 2 base stocks or Group 3 base stocks. And this is a dominant factor on why we're seeing such a high incidence of varnish these days. Is that a myth or not? What do you think?
Yes, there is that myth floating around in the industry. And I remember when back in the day, a lot of people, they were so scared of changing their oils from Group 1 to Group 2. And they're like, no, I can't do Group 2 because then that means I'm going to have varnish. And when there was a change from Group 1 to Group 2 base oils, there were also a lot of different changes going on in the industry. Like we had the OEMs changing the size of the sump, or, when they did that, the oil had a shorter time in which to dissipate the temperature or to get cooler. So yes, you had that increase in varnish, but that does not mean because it was Group 1 base oils. There's no data to support that.
That's a great point, Sanya. And I think one of the reasons that people assumed that Group 1s were less prone to varnish problems than Group 2s is because they have a higher aromatic content, which is polar, and therefore can attract varnish and keep it in solution, and has a greater ability to solubilize varnish. Although that is true, the actual oxidative stability of Group 1s are significantly less than the oxidative stability of Group 2s. If you had an old steam turbine system that had been running for years, for decades with Group 1 formulations, it's a pretty good chance that Group 2s may not provide a significant advantage. But if you have any modern turbo machinery applications or the latest industrial gas turbine applications, Group 2s will far and away outperform that of Group 1s. In order for us to validate this, we put several Group 1s and Group 2s through an accelerated oxidation test we refer to as the turbine oil performance prediction test. And sure enough, Group 1s produced a lot of deposits, significant amounts of deposits in a much, much shorter time frame than, say, a Group 2. Here is an example of a patch from a Group 1 turbine oil formulation after 5 weeks in our top bath. And today we can generally see Group 2s in many cases go for 12 weeks without producing a lot of deposits in the exact same test. All right, so now that we have that myth behind us, let's talk about one of the definitions that we have in Chapter 2 of the book. And Sanya, let me ask you, what is silting? And does this have anything to do with soil?
When I heard the word silting, immediately I thought about agriculture, but it has nothing to do with soil. Actually, what happens with silting is that this will occur when you have a lot of small particles that, they over time, they would help with, accelerated wear and eventually the failure of the equipment. What tends to happen is that you would have larger particles getting into the system, and then they get ground up by the gears, pumps, and, they make them a lot finer. And your filters, while they may filter out some of the particles that exist, they're not going to filter out all. There would be some small particles that remain. And eventually, the ratio of the small particles to the large particles would increase to a point that all of the small particles, they're going to gather onto the servo valve. And that's where we start having issues with malfunctions and, all of these not so great things in life. But one of the things with silting is that a lot of the components, they experience what we call the sandpaper effect. Now, in that effect, a lot of the smaller particles, they stick onto the varnish. So when they stick onto the varnish, they form an abrasive layer. And in that abrasive layer, they actually, wear against the other internals of the equipment. So you have an increase in friction, you have an increase in wear, you have an increase in operational costs, you have a lot more failures happening in your equipment. So the components actually become damaged because of this silting that has formed the sandpaper effect. So something to look out for, definitely.
Well, that was a pretty gritty subject. So let us move on now to something that we talk about in our next chapter, which is maybe you can explain what are some of the factors that impact the formation and chemistry of the varnish composites that we find in systems.
There are four main factors that people can look out for that affect the different types of the deposits. Some of the four main ones would be a mode of degradation. Now, when oil degrades, it's going to degrade in different ways, and being able to identify how it degraded would tell you a bit more about what's going on inside of your equipment. And depending on how it degrades, it would form a different type of deposit. So there are different modes of degradation, and that would affect the type of your deposit that's being produced. Your temperature of your reactions, your thermal degradation, that would be at like 200 degrees Celsius, whereas you have microdescent at 1,000 degrees Celsius. So different temperatures can produce different types of deposits. So your chemistry of your oil formulation is very important as well, because not all oils are produced the same way. You have hydraulic oils, you have gear oils, you have turbine oils, and they all have different ratios of additives in them and different types of additives as well. So this will influence the type of deposit that's being formed. Another thing that you want to take into consideration would be your type of contaminants. Now, every system gets contaminated at some point or another, whether it's somebody putting the wrong oil in there and you have an incompatible oil mixing in, or if it is that some contaminants get into the system from the outside. So being able to identify what your contaminants are, that helps to determine what your final chemistry of your deposit is. So that tells you a bit more about what's going on the inside of your system. So those are just some of the factors you can think about that affect your different types of deposits. Here's an interesting one for you, Greg. What is shear stress? And is this another breakdown mechanism? I really want to hear your thoughts on this one.
Sanya, that's a really interesting question. So in fact, shear stress is a different degradation mechanism. And before I dive into the details about what shear stress is, let's just review very quickly about how most people view varnish typically forming. So typically you have oil degradation, generate some byproducts that are polar in nature. These come out of solution, out of the non-polar oil, and these deposits form in the equipment, causing all sorts of reliability problems. The primary mechanism that's drawing these things out of solution in most cases is temperature. The oil is cooling down and you're reaching the saturation point, and then these degradation products come out of solution. So this is a very common form of oil degradation that we see across multiple lubricant applications, such as gas turbines, steam turbines, large frame units. However, what about in petrochemical applications when we're dealing with really fast-moving, high RPM compressors? This is an example of an 800 horsepower Elliott compressor that its bull gear speed is running at 3,500 RPM. Its first stage bearing is running at 37,000 RPM, and its second and third stage bearings are running at over 50,000 RPM. In this type of application, the oil can be exerted to a different type of stress that we refer to as shear stress. And so one of the common issues that we see with this type of application, we see a gradual increase in both vibration and temperature. And actually over time, especially the temperature resembles a sawtooth type pattern that increases over time. And this can be, in fact, a pretty concerning thing. So typically, at about 110 degrees C, we have a warning level. At about 120 degrees C, we have a trip. And if the unit actually doesn't shut down and the temperature continues to increase, at 132 degrees, you actually can have the Babbitt surface of the bearing starting to creep. One of the interesting things about this type of degradation mechanism is that we're talking about deposits that are happening directly at the heat source, directly on the bearing surface, and in fact, the rest of the oil may still have a low varnish potential. So in this case, this particular application, we had a very, very low MPC, even though we started to see some really elevated alarm levels. And so this is what shear stress degradation is. And it's a mechanism that causes very, very high localized temperatures. And unfortunately, MPC is not, in fact, a reliable way of detecting this. So some of the technologies that we may use to detect shear stress, vibration sensors, temperature probes, and also just physically inspecting components. If you see varnish occurring, especially on bearing surfaces, there's a good chance that shear stress may be at issue. So to understand shear stress, the couple factors that are really key for us to understand are the rotational speed and the actual load on the shaft. And the varnish formation occurs at the minimum oil film thickness zone. And the higher the rotational speed, the heavier the load, the higher chance of shear stress occurring and these localized deposits forming. So one of the challenges is that this is not simply a matter of just changing to a different type of oil. We have seen this issue with group 1 base, 2, 3, and even group 4 base formulations. When you have enough thermal stress on this, any type of fluid can degrade. If you can imagine actually what's happening at the varnish surface, and if we can magnify this, there's actually internal friction that's happening in this tiny little film of oil that's producing really, really high temperatures. So at least in excess of a couple hundred degrees C. So very high temperatures just internally in the oil. It's not causing the actual temperature probes and bearings to pick this up, but it's actually causing such a high amount of thermal stress that it causes the degradation products to not only form, but to actually come out of solution and plate out right there at the minimum oil film thickness region. And so this is also known as hot varnish, and over time you will have multiple layers of degradation products. We go into more detail in the book, but that's a quick summary of what shear stress degradation is. Okay, Sanya, time for a question for you. And as we know, in any application where oxidation is at play, the most critical ingredient in the industrial lubricant formulation are antioxidants. And so it's essential that we monitor these and know what actions to take when these start to become depleted. So maybe you can give us some guidelines on perhaps what operators can do to help maintain these various levels of antioxidants.
ASTM 4378, they actually declared that a turbine oil has reached its end of life when it gets to 25% antioxidants remaining in the oil. After it gets down to 25%, it actually starts to degrade a lot faster. So a couple of ways you can actually change that level of antioxidants within the oil, replenish your antioxidants. But this is not like making a cup of tea in that you can just pour any amount of sugar that you want. What you have to do with this, you have to make sure that you have compatibility with your additives. So it would require some testing upfront, some compatibility testing upfront, and make sure that your antioxidants and the additives, everything, works together. But this is really the easiest and the most cost-effective option because it doesn't require a lot of manpower or the shutting down of your equipment. So usually replenishing of your antioxidants, that is one of the ways, the easiest ways to actually get those numbers back up. Another way that, is prevalent within the industry is called the bleed and feed method. So in this method, what they do is that they actually replace parts of the oil from the original oil in the sump. So if you had, you would take out 25%, and the number could vary, 25, 30, 40%. You could take out 25% of your sump, of your old oil, and put new oil in there. If that is the only option that you have, then you can exercise it. But just be aware that if you put 25% in, you're not going to get a 25% increase in antioxidants. So just to be aware of that. There's another way that you can do it with full replacement of your oil. So in this case, you replace the entire sump of oil by new oil. If your oil actually had varnish before, you would want to clean that sump out and clean out all of the internals, all of the places that you may have varnish stuck in, and your new oil is not going to get the kind of benefits as it would if it is that it was just new clean oil in a clean system. So flushing is very important in those cases. Just one thing to be aware of when you're replacing your antioxidants, like trying to get those levels up. If you do a full replacement and you had some sort of varnish going on before, definitely clean out your sump. It helps so much.
Thank you, Sanya. Great answer. Well, it was our intention to give you a quick overview of some of the different chapters of our book, and I would say we actually weren't that successful. We made a long list of various different questions that we were going to go through, and we didn't get close to covering it all. So stay tuned for another part 2 or part 3 or part 4, or also consider getting the book. But we really appreciate you joining. Thank you so much, and enjoy the rest of the conference.
Thank you all so much for joining us and for, being part of our first book launch, unofficially, virtual book launch. And let us know if you have any questions. Well, you all heard from Greg and I, and
I'm not sure if we
Greg and I were just trying to get as much information in as possible. I don't think we have an entire book on it, right?
Yeah, we'll have a chance to dive into many more of these questions here.
Yes, definitely, because I know, and while I'm here, I just want to say a huge thank you to you. You did an amazing job with the foreword for the book, and it really gives a really good history of the industry and all of the things that happened. And if you did not know what happened in the past and how we got to this day and the stage, you gives a very, very thorough account of it in the book. So another reason to buy the book, because of you. Amazing job.
It looks like we do have a question
We
here.
have one. Oh boy. The best way to avoid varnish formation. There's so many ways to do that.
So I would, I'll just have the first go at this. I'll say the most effective way is to be proactive. We have so many people that come to us with all sorts of, really significant varnish problems. Their equipment is about to shut down. Their temperature spikes are going through. Their valves are sticking. The best way is to try to be proactive about this and take action before you have any reliability issues. But, if any of you saw Rafe's presentation on the future of the industry, he had a really good point, I thought, that there's a lot of advancements in formulations. And at some point, a lot of different types of varnish may be formulated out of these applications. And so we are certainly seeing a trend with better and better performing oils. So I think, 10 or 15 years from now, there will be less varnish. I don't know, 10 or 15 years. There are some very, very good oils today. Then, in fact, you can have a varnish-free system today, actually. And there's also varnish mitigation technology, solubility enhancers. So there's a wide range of options.
Yeah, and I just want to add to that, varnish is different for everybody. So I think the first thing you have to do is really analyze what's going on in your system and to understand your system first. Because if you don't understand what's going on in your system, you're going to be doing all sorts of different mitigation techniques and you'll be like, it's not working. But that's just because it wasn't designed for your system and for the varnish that is in your system. So always a good idea to understand what's going on first and then try to mitigate it. Prevention is also great. Nobody wants to get that 2 a.m. call and, here's something's going on with your equipment. Oh, yes. Right. And we have you asking, will an increase of solubility help to avoid it? Oh, boy. Well, that's an interesting question because I know, like in the book, we cover something like that in terms of varnish being in that cycle where it can redissolve into the oil. So I'm gonna pass that one off to you, Greg. You
Okay.
have the floor on that.
So I think you made I think this is one of the keys actually to
Mhm.
formulating varnish out of an oil formulation. If you notice comparing a group 1 to a group 2 to a group 3, group 4, there's less aromatic components as we get to a more highly refined base stock. But if you can use a group 4 oil, it's much more oxidatively stable. However, it can produce, it's not going to hold on to any varnish. So the ultimate solution for this is to increase the solubility of the oil. So you end up with a very strong, oxidatively strong base. However, you have technology that can prevent varnish from coming out of solution. And in fact, let me just rephrase that. Prevent oil degradation products from coming out of solution. Because varnish, there is no varnish in oil. It's only when varnish comes out of the oil and then actually plates the internals, as you said in the introduction on the definition of varnish. So it's managing the oil degradation products.
Oh yeah.
Really good question.
All the cholesterol involved in that. Yes, yes. Only when it deposits, then do we have a problem. If it stays in solution, we're okay for now. But I think that's one of the things, and a lot of people suffer with that in terms of they don't know how to manage the oil or how to monitor the oil properly to determine what's going on with the oil or to put certain things in place. And I think, I would love for AI to help us out there, just in case they could do that, bridge that gap a little bit. But AI is only powered by what we give it. So I think AI needs to read our book. Yeah. Yeah, we need to get AI to read our book.
So we had a customer today ask us a property of one of our products. We had no idea. And then they wrote back a little while later and said, oh, we got the answer with ChatGPT. It told us. So it's funny. ChatGPT makes up so much stuff. Anyway, it is a good tool, but we have a ways to go. I would not use AI to provide any references for papers, for example.
And we did not use ChatGPT to write this book. This is based purely on experience and what we've found out in the field and from, just going out with the customers and having that experience, because ChatGPT can't get onto the shop floor just yet. Just yet.
Yo just asked another question about sensors and detecting varnish online. So that's a really good question. I think there's not a sensor today that directly measures, say, the MPC test. Also, it's a little bit challenging because the MPC test, you actually have to take the oil out of service and then cool it down for 72 hours before you can before this stuff comes out of solution and you can measure it on the patch. So having an inline measurement for the MPC test directly is really challenging, and I don't think that exists yet. However, there are some really good tools that will help monitor oil degradation. So we're using one technology right now that is measuring all of the degradation of oils that we've then been able to correlate to the MPC test. So it's not directly measuring the MPC or the varnish potential, but indirectly we can correlate that data to do so.
Yeah, and I see Ahmed has a question. Does using lower ISO VG oils help? That is a very interesting question, because when the lower your viscosity of your oil, you are possibly gonna your system is gonna have to be designed for that. Because if you have a lower viscosity, that means that you have smaller clearances, which means you have more pressure on your oil. So it has to perform a lot better. So I can't say that lowering the viscosity will help with your varnish per se, because it all links back to your system. What do you think, Greg?
Yeah, that's a really good. You're exactly right. It comes down to the application. So we talked a little bit about shear stress, and shear stress is this incredibly thin oil film. That's and if you're using a lower viscosity oil, theoretically, that film, it's going to be a little smaller film, and shear stress could in fact occur more. On the other hand, a little lower viscosity oil will lower the friction between moving parts and will also speed up cooling. So that's a very complex question that I think really does come down to the application. But yeah, I love that question.
That's a good question. So I think we're at the end of our session. Thank you all so much for joining us. And we hope that we were able to add some sort of value. What you didn't get from this session, you can get it in the book for sure. So check out the book. It's available. And enjoy the rest of LRVS. Thanks for joining us, Greg.
Thanks, everyone. All right.
Bye.